We had left off with number 6 on the probability test review sheet, and it continues with the idea of expected value. Alright, now the little difference with number 6 is that it involves 3 separate scenarios. Okay, you get to select a colored ball at random from a bag containing 8 green, 8 red, and 20 yellow balls. So there's 3 situations. One if you select the green, one if you select the red, and one if you select the yellow. So if you select the green, you win $9. If you select the red, you win $2. And if you select the yellow, you lose $3. So here's the 3 scenarios. There's one here. There's one here. And there's one here. Okay, so if we just take them in order, right, we're going to use expected value equals A1 P1 plus A2 P2 plus A3 P3. Or, I mean, you can write it in order. You could write it P1 A1 plus P2 A2 plus P3 A3. The order doesn't matter there with the multiplication. So P1 is going to be the probability of selecting a green ball, and there's 8 greens out of a total of 36 balls total. Right? So the probability of selecting a green would be 8 out of 36, which would reduce to 2 out of 9. And A1 is the amount that you win if you get a green ball, which would be $9. P2 is going to be the probability of selecting a green ball, a red ball, and there's 8 reds. So again, the probability of selecting a red would be 8 out of 36, which is 2/9. And then if you select a red ball, you would win $2, so A2 is $2, or just 2. And then P3 is going to be the probability of selecting a yellow ball, and there's 20 yellows out of 36, which reduces to 5/9. And then of course A3 is the amount that you lose if you select the yellow. So if you lose, it would be -3. And now I'm just going to multiply all these numbers together and add them up, right? So A1 P1 is just going to be 9 times 2/9. A2 P2 is going to be 2 times 2/9. And A3 P3 is going to be -3 times 5/9. And again, the thing to notice is that all the p's add up to 1, right? 2/9, 2/9, and 5/9 equals 1. So this ends up being 18/9, which is just going to be 2, plus 4/9 minus 15/9. So actually this is going to be 22 minus 15, which is going to be 7/9. And that would be the exact form. If you want to go to the nearest cent, you would say it's approximately 78 cents, because 7/9 is 0.7 repeating. But if you want the exact value, it's 7/9. It all depends on what they're looking for. So 7/9 or 0.78. So in that case, you'd be expected to win in the long run. Right? You'd be expected to come out on the positive end. Alright, now 7 is a selecting 2 shirts without replacement problem, choosing from 4 shirts. Alright, there's a gray, a red, a blue, and a black. And the first part just says make a tree diagram and list the sample space. So if you're selecting these shirts without replacement, that means you can't get the same shirt twice. So what you'd end up having is you'd have one level for your first shirt, and then a second level for the second shirt. So when you select the first shirt, there's actually going to be 4 possibilities, right? You could either get the gray, the red, the blue, or the black. Call that K. Now, this is where these are different than, this one is different than the ones that we've done generally in the past. You can't choose the same shirt twice. So if you get the gray one on the first selection, you can't get the gray one again. So now you only have 3 possibilities for the second one. It could be red, blue, or black. And then you have a similar thing if you choose the red first. You can't get the red again, so you could either get the gray, the blue, or the black. And then if you get the blue first, you can get the gray, the red, or the black. And then if you get the black first, you can get the gray, the red, or the blue. And that's kind of messy, so I apologize for that. But again, like I say with these, the tree diagram is not really what I'm interested in. What I'm really interested in is the sample space. So the sample space would be GR, GB, GK, and then RG, RB, RK, BG, BR, BK, and then KG, KR, KB. So there's 12 possibilities altogether. So there's your sample space. That's A. And how many outcomes are there? There's 12 possible outcomes. What's the probability of picking a black t-shirt? Well, just count up all the ones that have a K in here. 1, 2, 3, 4, 5, 6. So the probability of picking a black t-shirt is actually 6 out of 12, or just 1/2. And then what's the probability of picking a blue t-shirt first, then picking a red t-shirt? Well, in this case, you're specifically looking for that combination of blue-red, and that actually only happens 1 time. So D is just going to be 1/12. And then E, what's the probability of picking a gray and red t-shirt in any order? So that means it could be gray-red or red-gray. So here's your gray-red. Here's your red-gray. So in this case, that's going to be 2 out of 12, or 1/6. Okay. So it's nice when you have the sample space there, because then you can just use the sample space to answer all the probability questions. Alright. Now 8 is a similar kind of problem, except now it's done with replacement. You're choosing from a $1 bill, a $5 bill, a $10 bill, and a $20 bill, and after you choose the first bill, you're putting it back in the wallet and then selecting a second one. So in this case, you can get the same bill twice. So the tree diagram, again, which is not really what I'm looking for. I'm looking for the sample space, but the tree diagram, you'd have a level for the first bill and you'd have a level for the second bill. So the first bill could either be 1, 5, 10, or 20. And again, now here's the difference between this and the last problem. I can then get the 1 again, 5, 10, or 20. And this pattern is going to repeat itself three more times, right? 1, 5, 10, 20, 1, 5, 10, 20, 1, 5, 10, 20. So what's my sample space? I can get a 1, 1, a 1, 5, a 1, 10, a 1, 20, a 5, 1, 5, 5, 5, 10, 5, 20, 10, 1, 10, 5, 10, 10, 10, 20, or 21, 25, 20, 10, 20, 20. So there's your sample space. So there's really a total of 16 outcomes, right? I could have gotten to 16 also by doing counting principle. I could have said, all right, for my first selection I have 4 choices, and for my second selection I have 4 choices. So 4 times 4 is 16. You could have gotten it without the tree diagram. And then see what's the probability of selecting a $20 bill. So count up all the ones that have a 20 in it. There's 1, 2, 3, 4, 5, 6, 7. So there's 7 out of 16. And then what's the probability of selecting a $1 bill first, then a $10 bill? Now that scenario only happens once. 1 followed by a 10. So the probability of that is 1 out of 16. Right? If it was in either order, then it would be 2 out of 16, because then it could have been 1, 10 or 10, 1. But in this case, it had to be in that particular order. Alright, I guess we'll look at one more of these. Of the patients examined at a local clinic, 25% had high blood pressure, 50% were overweight, and 15% had both conditions. So, are the two events mutually exclusive? High blood pressure and overweight. Well, right here, the fact that 15% had both conditions tells you that the answer to that question is no. And the reason being is there are people who have both conditions. So when there's people that have both conditions, or in other words, when there's outcomes that the two have in common, the events are not mutually exclusive. So the idea of that is, if I want to find the probability that a patient selected at random has high blood pressure or is overweight, I would say the probability of H or O, meaning high blood pressure or overweight, would be the probability of high blood pressure plus the probability of being overweight, but then I have to subtract the probability that they have high blood pressure and are overweight. So it just becomes a matter of adding the 25% that have high blood pressure to the 50% that are overweight, and then subtracting out the 15% that have both conditions. So this is 75% minus 15%, so it's 0.60. So the probability of the patient having high blood pressure or being overweight would be 0.60, or 60%.